Hello, welcome everyone. This is VFitter University. I am Elijah and we are here with Paul Spaur. As you guys may know, we are the first practical university in the entire world, and we are focused on practical learning, practical knowledge, and basically turning knowledge, existing knowledge, into wisdom, which comes with a lot of practice, experimentation, and simulation. Thank you so much, Paul, for being here. I'm very happy to have you. These people don't know you yet, but we can't wait. Please introduce
Great.
yourself and tell us about your mission, what this is all about, basically. Thank you.
So my name is Paul Spaur. I'm the CEO and founder of Metago. And Metago is a platform for the hosting, sharing, and collaboration on 3D geospatial data. So what that means is any kind of data with a geolocation associated with it. So that could be images, pictures, 3D scans, rasters, and more technical vectors. So basically any kind of data with a geotag associated with it. And our mission really is to be able to bring this kind of data and take it out of the silos that it currently exists in. And so currently you'll have companies that are doing construction, maintaining businesses or buildings, property, land, environment. And so all of this different things that are being managed requires to have a spatial understanding of that environment. And so that means that if you have buildings, you understand what the shape, the height, the conditions, and document that over time. But then also being able to look at how things change with the environment, different kinds of weather events, different kinds of basically maintenance events. And so bringing all of this spatially or dimensionally bits of data into one platform that you can visualize in 3D and then be able to communicate that across teams is really what we're looking towards. And then the future of that, bringing that data that exists either in hard drives or in the public domain and being able to utilize that for future developments in augmented and virtual reality.
Oh, wow. This is great mission. And in my opinion, because we've used a lot with GIS and all these platforms that offer feature servers. How do you see the whole simulation in that area? And what are the sort of simulations and experimentations that you're looking for to be able to offer a practical solution to your clients?
So in the world of simulation, specifically with regards to geospatial data, I mean, there's a lot of things you can do.
Exactly.
Having this information first as a foundation for simulation is really super valuable. For example, let's say that you have a city and you want to understand what are the potential environmental risks. If you have a 3D scan of an entire city with the elevation and topography, heights of buildings, that sort of thing, you can simulate what a windstorm might do if it comes ripping through city buildings. Or if there's flooding, you can see where the high parts are. So you can get an estimate of where water might go to because of the topography, because of the shape of the buildings. And really interesting experience that I've had working with this 3D scanning, 3D mapping data is one time I was working with a group that was trying to investigate an accident that had happened. And there was a vehicle that had flipped over and they weren't quite sure why. And so there didn't seem to be an accident. They had not a lot of evidence as to what happened because there was no security cameras. And what they were able to determine through simulation is that there was a windstorm event. And because of the shape of the buildings and because the damage that had occurred, it basically caused an aircraft to roll over. And so that simulation was able to help prove, based upon historical records of the weather, the shape of the environment, basically how that had happened.
Oh, wow. This is very interesting. As you're explaining, this can save the world, literally. All the problems on Earth, including earthquake. I don't know if you know, because most insurance companies, they don't cover earthquake. And it's really weird that something like this has been around for decades and we still can't figure it out how to solve it, right? So it's like, what are the solutions? We have to gather information, as much as information as we need, data, and then visualize it and get ideas on how to do specific things. When you're talking about data and visualizations, are the data that you guys are producing, is it possible that we read that data with large language models and artificial intelligence?
Yeah, so AI has a really great place, as does large language models. So with the current data that exists, so I'll talk about data sources really quick. So talk about data sources first. If you consider either satellites, airplanes, drones, mobile phones, self-driving cars, these are all very different sources of data that come in different formats. And one of the problems is getting all of them into a communal or an environment where all of the different data types can come in. And then once you get them all into this same environment, then you can start leveraging AI analytics and large language models to perform different kinds of tasks. For example, I mentioned location-based data. All of this data can exist in CSV files. So it's all tabulated data that could be basically gone through, looked at for trends using AI analytics. And not only just trends, but when you're talking about photos, your photo is a cell of numerical values for each pixel, right? And so with that, AI analytics can be run to generate statistics on certain things. And there are AI models out there that are used to determine what the content of pictures are. So we're all familiar with Facebook having AI analytics to detect faces and to detect faces and to detect different contents of images. We can do the same thing with aerial photos and 3D scans, where you can use an AI algorithm to take a satellite photo or a drone photo and say, for example, count how many trees are in it. And so with that, you can start building foundational knowledge on the environment, not just from a visual perspective, but from a data perspective. And so expanding on that, you can count how many trees are in a forest. How big is the span of developed land versus undeveloped land? And so going into the large language model side of things, you can start using those kinds of algorithms to actually answer some of the questions. And furthermore, actually do some of the work. So a good friend of mine, he has been experimenting. He's a surveyor. He's a land surveyor. And what he does is he experiments a lot with ChatGPT and different language models to not only be able to get understanding of certain situations by asking a question like how many homes are in this area based upon this text file that has a bunch of different addresses or that sort of thing. But moreover, he can actually ask it to write an algorithm that will help put out a map that would generate information, or rather visual information, using CAD or GIS. And you can actually say, I want to accomplish this task, and it will actually kick out scripts in order to be able to facilitate some of these things that they're trying to do. And so what it ends up doing is saving people who have to do this kind of work on a daily basis lots of time, because it's actually kicking out a script that will do the thing that they would spend 100 clicks doing.
Oh, wow, interesting. I'm mind blown. So for the audience, I don't think anybody here knows, but please educate us on your experience at Intel.
So I came to Intel Corporation because of my experience with 3D mapping and modeling. So previous to Intel, I actually worked at a company called Pix4D, and that company it's a science and software that performs photogrammetry. And so photogrammetry, for those that don't know, it's basically using computer vision and some pretty tried and true science and methodologies to take photos and create 3D scans with them. So essentially, if you have photos that have overlapping content, you basically can have parallel, just like our eyes. We have depth perception because we have two eyes, and we can have depth perception, reach out and touch something because there's triangulation that happens there. And the software does that by being able to have multiple photos, of which now you have multiple perspectives and more parallax to create 3D understanding of environments. And so with that software was basically something that became very prevalent in the drone and aerial photography and mapping worlds. And so Intel had actually hired me from Pix4D to come help work on their drone program. Oh, wow. So they had a drone program where they were using not only just basic cameras, but advanced cameras to use on drones to do 3D scanning and create maps and models. And so I went to work with the Intel team to do that. Unfortunately, right when COVID hit, decided to change directions and focus more on the core business. And so that team at sunset, but at the same time, I had gone on and taken an opportunity to go work with the Olympics. And so with Intel and with the Olympics, we went and we used drones to 3D scan 4 different Olympic venues in Switzerland and France.
Oh,
And
wow.
so we took these 3D scans that we made on a massive scale and created a VR Air app where we could take those 3D models, put it on your coffee table at home,
Oh, wow.
and then you could use your phone as a looking glass using augmented reality to be able to see the mountain, walk around it, look at the different components, like the different tracks, get the stats of the athletes, see where they are. And then they had 360 cameras where you can click on a 360 camera and chase the athletes down the mountain as they were going down. And
Jesus.
so it was almost as if you're there, right? Because you can
Yeah.
change your perspective, and it's a 360 VR camera. So you're able to look around as if you were standing on the sidelines.
Oh,
And
wow.
so that actually fueled my passion for mixing augmented and virtual reality along with geospatial data.
This is the perfect combination of AR and VR, basically, right? So it's like you gathered everything, you made it VR, and then you made it the 3 printed version is now capable of AR processing and giving information in the most practical way. This is interesting.
The way that I see it is there's all this data that exists on top
Mm.
of our world that we can perceive with our eyes.
Yeah.
Each city, each county, each state, each country, they all have geospatial data that exists, and so do private companies. And so my vision is that the more that we incorporate augmented reality into mobile devices, whether it's a headset or not, we're going to start being able to tap in to these invisible layers of data that's based upon your location. So you're walking down the street, you look at your favorite restaurant, there's going to be the ability to pull that geolocation, show you the menu, and show you pertinent information on what you want to know. And if you're more on the transportation and on the maintenance and inspection side of things, say that you're a bridge inspector, you could look at a bridge and then see all the history of the maintenance that's been performed on it. You understand what materials were used to construct it. When and then using AI analytics going forward, you can then have predictive maintenance indications. Maybe there's a certain part of the bridge that's been decaying faster and faster over the years because you've been scanning it on a regular basis. It might be able to identify places where you might need to do maintenance in the coming future.
That's super interesting, man. Just to let you know, we've done some geospatial analysis and stuff like geofencing on our platform, and we kind of merged S3 mapping with ArcGIS and AI in a way that you would basically select a zone, geofencing, and it would get that information that you're looking for as the feature server, some sort of like JSON file, and then it would feed it into AI, and then we would talk to that specific area of the map. There
Yeah,
are
perfect.
Yeah, we did a lot of testing on that, and it kind of worked. But when we were testing different large language models, because we are integrated with almost all of them, when we were testing it, we realized that GPT still has the best reasoning out of all when it comes to geospatial processing and information gathering. We also try to mix it with Places API from Google to get that restaurant information and all the places nearby. But sometimes it actually knew the information of the places without even having to use that API. So that was huge. Do you think our future of AGI would be covering geospatial information, all of it, or would it be very dynamic?
Well, so one of the issues is training any kind of AI. It's all about the data set you train it on, right? It only knows what it's been exposed to. And so one of the hard things is that with geospatial data is that sometimes it lives in places that you can't access or that you don't know how to access. So the Places API with Google, it's a great aggregation of a lot of that data, but there's still more out there.
Exactly.
So the way that I see it and the way that Metageo we're kind of positioning ourselves is to be an aggregator of aggregators, so to speak, to be able to help combine all the different geospatial data from public sources and have that in this additional layer. And then really going forward, the better that these models are trained on this data, the more comprehensive it'll be. And then so I'm not quite sure about how updating and currency of that data will be affected by the language models. So that's something we have to see. And that would maybe more be like a active integration with an API so it can continuously learn.
Yes. And I was thinking it can learn on demand. It doesn't necessarily have
Yeah.
to learn it all in one giant database. We could just search and then feed that specific data that we're working on, which is very
Yeah.
efficient. Awesome. So in your company, you said you're doing 3D visualization and you're offering it to different industries. What are the main industries that you see this technology benefit the most?
Well, really, in the immediate future, it's the ones who have already been using it. And so oftentimes when you're working with geospatial data, there's a few different kinds, right? There's the lighter, more layers, kind of polygons, tabular information. That's somewhat light as far as sharing and distributing between teams. But when you get into the 3D data, that's when things get kind of heavy. And so oftentimes when you're talking about a data set for even just a city, you're talking about having polygons for different buildings and that sort of thing. You're talking about maybe a few hundred megabytes, maybe a terabyte. But when you're talking about 3D data at a high resolution for an entire city, you might be talking hundreds of terabytes to petabytes.
I agree. You know exactly what you mean. Vertices, polygons, and it's going to be huge. And it's not like 3D data can help a lot with the actual processing and stuff. I feel like 3D is more for human understanding of 3 dimensions, for human to see how it looks like and help visualize better. But do you think it's also useful for large language models to access 3D information? I don't know if it's like the polygon position, how far is this polygon from that polygon? I think it can be useful. What do you think?
Well, so on the 3D side of things, I would say that what's more useful than, well, yes, the visualization component is pretty useful. And depends if you're talking about 3D meshes or 3D point clouds and how it's derived, whether it's more of a generative process, which means that there's some areas being filled in, maybe predictively or maybe algorithmically, or if it was sensed, meaning that it's remotely sensed and not filled in and you have accurate measurements. I think the accurate measurements are more of a value than the visualization, depending upon what the specific task is. But with regards to large language models, I think that having a 3D understanding of at least the basics, like heights of buildings, areas of land, that sort of thing, I think that is pretty valuable because as we know as humans, the world is not 2D. We have flat maps, but the world is not flat.
There are some debates around that, bro. Don't let me bring it up. Earth is flat.
That is true. There are some debates, but I think that there's some really great satellite-based pictures which debunk some of those things. But
exactly. But bro, there's always some guy researching into stuff and sending cameras up to the space, coming up with these flat Earth theories. But it's all over the internet, and it's one of the most banned topics on YouTube. It's not gonna show you all the good evidence when you search it, all the debunked versions. But so back to our conversation. So right now in your company, I don't know if you've heard the term exponential organizations. I believe you guys are exponential organizations. That means that you have a small amount of employee, and that makes you operate faster, as opposed to giant corporations that everything has to be passed around between departments, and it takes months to test, trial, and it's sometimes super risky. But I believe you guys are exponential organizations. You're using technology as well as human. But how do you see your company scaling in future, right? How do you see that? How are we going to hire people? And is there new roles that added during the past couple of years that you can now employ as your main people?
Yeah, so that's a great question. We are a small team, and when it comes down to it, not having the red tape, so to speak, and having to go for multi-department approvals and budget approvals, we're able to pivot and change as technology advances. And that's one of the things. Technology is advancing at a super rapid rate, which we've seen, especially in the AI field the past few years. It's just building so fast that if you can't keep up with it, it's going to be difficult to survive. And so we're definitely lucky in the fact that we're able to move with the technology as it improves. And to your point, with the new coming age of technology within AI, there's new positions that are being created every day. There's prompt engineers. If you asked me if there was going to be a job whose job is to speak with AI and tell it, or rather coerce it to do what you want to do, I would have thought you're crazy. And so now we're seeing these positions that really are focused on gaining benefit from these different systems that are being developed. How do you put these things to practice? What's that?
Asking the right questions, basically.
Exactly. Asking it the right way, and then being able to ask it in such a way that you get the complete answer versus just a partial answer. And so how that works in our organization is currently we are working on a number of internal tools, but we're also partnering with external companies that are working on these different kinds of algorithms, or specifically working with models that are already trained and some that are not. And so as we go into the future, I think the way that we're going to be successful is by really having the proper ecosystem, because not one tool is going to be able to present a full picture. And that's one thing we're really big about is interoperability. So not only of the different analytics that you can run, but interoperability of that data that you bring in, right? So we're agnostic to where the data comes from, but our big goal is to take all the data from, as I mentioned, satellites, airplanes, self-driving cars, IoT sensors, bring all of that into one environment, so then you can then leverage those tools down the line. And so really having interoperability and having the ecosystem is, I think, the way that we're going to really go forward and really expand quickly.
Exactly. So just to give you quickly an idea of what we do, you said the ecosystem. We actually built like this ecosystem of all-in-one AI platform that would let you create different simulators and test different functionalities with different databases, different language models, and different variables, right? So it's not just one giant prompt. You could break it down into different variables and test it way faster. So our company is just like, I don't know if you see the GPT builder. That one was created mostly for chat and B2C customers. We are more focused on simulations. We want to really test out everything, every knowledge in this world, and get rid of the ones that are not useful, keep the ones that are practical and help us fix Earth problems. Because I removed this part, don't worry.
No worries.
So it's like we are this giant all-in-one company, and we are building a B2B ecosystem for companies to like levels, who has access to this simulator, that simulator. And biggest purpose is really just to practice knowledge and make it wisdom.
Yeah, at the end of the day, you can have the best, coolest tool that's out there, but if it doesn't derive wisdom, as you say, or value, then there's not a lot of point in doing it in business. Yeah, I completely agree.
Exactly. Thank you so much. Any final words for the audience?
Yeah, and thank you for the time. And really, it's really amazing how fast the technology has been advancing. And really, the Earth is that we live on, and we have to manage, and we have to plan around it, and we have to really take all the information we can and use it to make it better. And I think that with the advancement of sensing technology, remote sensing technology specifically, AI together is the perfect combination to really understand, analyze, compare, and really help predict how to meet challenges as they occur.
Exactly. Very interested in what you guys do, and believe this is one of the most practical things that is like on Earth, is to analyze Earth, right? And you guys are doing it, and do experimentations on top of it, and fix the entire world with this technology.
Cool, absolutely.
Yeah. Thank you so much for being here. It was very nice speaking to you, and we have a conversation like in the next few months, and bring it from there. Thank you so much.
Awesome. Thank you. I look forward to it.
Take care, man. Have a great day.
All right. Bye-bye.
Bye-bye.